Welcome to the FLIR T-Series tutorial that covers the basics of operating your thermal imager. Before we start, it is important to remember that knowing how to use this camera is just the first step. To get the most out of your thermal imager, thermographers must also understand how to interpret what they're seeing, and that includes how to accurately measure temperatures. Now, as an example, the side of this house really isn't cold, and this electrical equipment isn't hot. And it's only with certification training that you'll understand what's really happening here and what you can do about it. Emissivity is another important topic you'll hear us mention at least several times throughout this tutorial. It's a material property that has a tremendous impact on temperature accuracy. To demonstrate what we're talking about, here's another example. Check out the measured values on this disconnect in an outdoor substation using 3 different emissivities. At a setting of 0.9, it's almost 118 degrees Fahrenheit, or about 48 degrees Celsius. At 0.6, it rises to 139 Fahrenheit. And finally, at 0.3, we see 194. So which is it? Now, while this tutorial will show you how to change emissivity in your thermal imager, it's only with certification training that you'll learn how to determine the correct value to capture accurate temperatures. Speaking of which, if you're ready to get certified, stay tuned until the end of this presentation for a special offer to attend a certification course with the Infrared Training Center. Throughout the year, the Infrared Training Center offers hundreds of dates at a number of convenient locations, including online certification courses too. Head to infraredtraining.com to learn more. For now, let's get on to the basics of the FLIR T-Series thermal imager. The FLIR T-Series is a high-performance line of thermal imaging cameras that are used for a variety of applications, including electrical, mechanical, buildings, and more. It's available in several configurations, whether it's the 500 or 800 series, with all offering various resolutions and multiple temperature ranges. There's also the functionality that thermographers have come to expect from a thermal imager these days, including access to a variety of measurement tools, color palettes, and more that we'll cover here in a moment. 2 batteries are included, with each offering approximately 4 hours of runtime, and the cameras come configured to work with optional lenses that allow thermographers to inspect at a variety of distances. To change lenses, face the camera directly and turn the blue lock ring counterclockwise until the lens detaches from the camera. Gently lift the lens off and replace it with another. Turn the blue ring back clockwise until the new lens locks into place. When doing so, make sure the white mark lines up with the raised black rubber marker located on the outer ring of the lens. The FLIR T-Series also works with FLIR Ignite, a cloud-based data management system that automatically syncs your saved images. This allows you to view and edit saved photos, as well as generate inspection reports from any device using your Ignite account. We'll have more on Ignite a little bit later as well. For now, let's move on to the basics of camera operation. To help with that, I've got my FLIR coffee mug here, which we'll use as a target for these demonstrations. For those of you that want to follow along, feel free to pause the video, grab yourself a cup of coffee or a glass of warm water, and come right back. The FLIR T-Series comes with 2 batteries and a charger, each one taking up to 3 hours to charge. To insert a fresh battery, slide it into the bottom of the thermal imager until it clicks into place. To turn the camera on, hold down the power button until the FLIR logo appears on the display. The camera may then take a few seconds to load, but you should very quickly see a live thermal image. Next, let's talk about the control buttons found on the thermal imager. On the back of the camera, besides the power button, there's also the back button, which backs you out of any on-screen menu or selected option. The navigation pad, with its center push button, is used to navigate around the main menu, highlighting the various options. Pressing on the center button opens the main menu. This also selects whatever you have highlighted on the screen. Meanwhile, the navigation pad has left and right and up and down controls that you can use to move around the menu. The Image Archive or Playback button opens saved images and videos. And finally, there's a programmable button which can be customized and set to a specific function that is commonly used when operating the camera. To configure this feature, press and hold the button for about 2 seconds to bring up a list of available functions. Use the navigation pad to scroll down to highlight the desired command, and press the center button on the navigation pad to set the option. On the front of the camera, you will find the autofocus button. This can be used as an alternative to manually focusing the thermal image. And the save button is what you press when capturing images. On the bottom of the thermal imager, we see the laser button. This turns the laser on and off. Besides being used to calculate target distance, the laser can help as a visual guide to show operators where they're pointing the camera. There is also another programmable button similar to the one found on the back of the thermal imager. Finally, on the lens housing, there is of course the infrared camera lens. It's a good time to mention that you should also avoid touching the lens. Infrared camera lenses have a special coating on them that play an important role in the camera's ability to measure temperatures. If that coating gets damaged or worn off, it will affect the accuracy of your temperature readings. Procedures on how to properly clean a lens can be found in your user manual. A good rule to follow is to try and clean the lens as little as possible, so be sure to use your lens cover whenever you put the camera down. There is also a digital camera that captures visible light control photos when saving an image. 2 LED lamps are also included. These illuminate the scene, helping operators capture better visible light photos in low light conditions. The laser transmitter is where the beam originates from when activated. This works in conjunction with the laser receiver, which is used to measure and calculate your distance to target. Now is a good time to also mention that the FLIR T-Series thermal imager is touchscreen driven. Tap the 3 dots seen here at the bottom of the display to open the main menu. Pressing the center button on the navigation pad does the same thing and will likely be necessary if you're wearing gloves. There's also a hidden menu that you can access by swiping down from the top of the display. Here you can turn Bluetooth and Wi-Fi on or off. Sign into your Ignite account to automatically upload saved images to the cloud, and activate the LED lamp to illuminate your target. There is also a slider here on the right that adjusts the brightness of your display. Swipe back up to return to a live image. Finally, at the bottom of the display, you will find additional controls that operate several important functions. The scale icon is used to toggle the camera between manual and automatic adjustment modes for thermal tuning. We'll cover that a little bit later. The overlay button turns the on-screen graphics on or off. Here is where you can turn continuous autofocus on or off. When enabled, the camera will constantly autofocus as you move around. This also turns the laser on, so it is best to avoid pointing the camera at a person when using this function. This option controls the LED lamp, turning it on and off. And finally, work folders is where you can create subfolders to help keep your saved images organized. Let's take some time to explore more of the camera's features and the various settings that you'll want to configure. Having the correct date and time entered into your camera is important for proper documentation and record keeping. These values are tied to each file when you save a thermal image and cannot be changed afterwards. To set the date and time, navigate to the Settings menu using either the touchscreen or the navigation pad. Select Device Settings, and then Language, Time, and Units. Under Date and Time, you should see options to set your time format, the date format, and the time zone. As for setting the date and time, if you're connected to a Wi-Fi network, this should update automatically. If not, I'll show you how to connect to a network a little bit later on. For now, you can use the field to make manual adjustments. Highlight the Time field and press the center button on the navigation pad to open. Pushing right and left on the navigation pad brings you to the desired field. Once highlighted, pushing the navigation pad up and down will change that value. Once the fields are set, press the back button to return to the date and time submenu. Repeat this process to set the correct date. Press the back button to return to the language, time, and units submenu. Using the navigation pad, this is where you can change the units from Fahrenheit to Celsius or the distance values from feet to meters. Press the back button to return to a live image. The range covers an interval of temperatures the detector can accurately measure without going into saturation. You work within a range, and when saving an image, all of the temperature data in that particular range is captured. The T-Series thermal imager offers at least 2 temperature ranges depending on the model you're operating. Bring up the main menu by pressing the navigation pad or touching the menu icon at the bottom of the display. Navigate to Settings and then select Camera Temperature Range. This particular T-Series thermal imager has 3 ranges, the first covering temperatures from -20 to 120 degrees Celsius. Range 2 provides the ability to see objects up to 650 degrees Celsius, and Range 3 up to 1500. Select your desired range, with Range 1 being the most appropriate to use for any targets that are below 120 degrees Celsius. Remember that range is not something you can change after saving an image, so be sure to have the correct range selected before capturing any data. Focus is another adjustment that must be set correctly before saving any data. You cannot change focus after saving a thermal image or video. The T-Series thermal imager offers 3 options for focus: automatic, manual, and continuous autofocus. Hold down the autofocus button on the front of the camera to operate this feature. The button is located right above where you press to save an image. The camera will automatically focus on the target. For this to work properly, however, the target must have good thermal contrast between hot and cold surfaces. If your target is closer to the temperature of the ambient environment or very uniform in temperature, autofocus may not work as well. In these situations, or if it's preferred, operators can use manual focus instead. Turn the focus ring on the lens housing until your image is in focus. The T-Series also offers continuous autofocus. Press the continuous autofocus icon located just below the display to turn on this function. When enabled, the thermal imager will continuously adjust focus as you move the camera around. It's important to mention that this also turns on the laser distance meter, so be careful about where the laser is pointing. The FLIR T-Series thermal imager comes with several different imaging modes that allow you to customize how targets are displayed on the screen. This includes thermal MSX, which adds visible light details to the infrared image. MSX stands for multispectral dynamic imaging and improves contrast by superimposing visible light elements that are not normally seen by the infrared camera. This can include equipment labels, breaker numbers, or patterns on objects. Navigate to the main menu and select Image Mode to change this view setting. The following options are available: Thermal MSX, Full Thermal, Picture-in-Picture, and Digital Camera Only. Now, while many thermographers typically use full thermal, many others also seem to enjoy working with MSX as it provides both thermal and visible light data that enhances important details and can help you better identify your target. The FLIR T-Series saves both thermal images and video and also provides an option to capture time-lapse sequences. This recording mode can be changed from the main menu. Operators can toggle between still photo, video, and time-lapse. Select the desired recording mode, and when you press the Save Image button, the thermal imager will save data in that format. Thermal tuning is the process of changing the temperature scale in the camera. This is what we call adjusting span and level. Modifying the scale changes the brightness and contrast of the thermal image, helping you better identify thermal anomalies on the target. The camera is typically set to automatic adjustment mode by default. This automatically changes the scale based on the hottest and coldest objects in the field of view. There may be times, however, when manual adjustment is required. This is especially true when there are extraneous hot or cold targets in the frame. Press the scale icon at the bottom of the display to toggle between automatic and manual modes. Turning on manual mode will highlight the top and bottom temperature values on the scale. Pressing left or right on the navigation pad allows you to select one or both numbers. Once a number is highlighted, press up and down on the navigation pad to change its value. To demonstrate, I've highlighted the top number. Pressing down on the navigation pad lowers this value, narrowing the span. Notice how the contrast changes. We can do the same with the bottom number, again highlighting it by pressing left or right on the navigation pad. Once highlighted, pushing up or down changes the value. Highlighting both numbers together allows you to adjust level. This keeps the span fixed and instead changes the position of the scale within the range of the camera. In manual mode, you also have access to one-touch auto adjustment. Tap any area on the display to automatically readjust the scale based on where you've touched the image on the screen. In this example, let's get rid of the saturation on the coffee mug. Pressing the screen once readjusts the scale. Finally, the virtual slider displayed on the image also provides touch control to adjust span and level. Simply tap which number you would like to adjust and then swipe up or down on the slider to either raise or lower that value. The FLIR T-Series comes with a number of different color palettes that allow you to add varying levels of contrast to the thermal image. Open the main menu and navigate to the color palette icon. Press the navigation pad to open the color palette submenu and use the navigation pad to select your desired color palette. These include iron, rainbow, rainbow high contrast, white hot, black hot, Arctic, and lava. Color palettes can also be changed after saving an image either on the camera or in your reporting software such as Thermal Studio or FLIR Ignite. Isootherms, or color alarms, are also available on the T-Series thermal imager. This feature highlights a region of apparent temperatures in the thermal image, emphasizing certain areas to help with analysis. To access isotherms, open the color palette menu and navigate to the right where you'll see the following color alarms available, including an above alarm, below, interval, condensation, and insulation. Let's demonstrate the above alarm using our FLIR coffee mug. If we set the above alarm to 30 Celsius, anything that has an apparent temperature in the field of view above 30 degrees will be highlighted in red. The color palette option next to the temperature threshold allows you to select what color palette you would like to apply using the isotherm. Typically, isotherms work best when used with more monochromatic color palettes such as the white hot or black hot. This helps simplify the image and allows the color alarm to stand out. Measurement tools allow you to add temperature data to your thermal image. The FLIR T-Series thermal imager offers a number of different measurement tools. These can be found in the main menu under the measurement icon and include No Measurements. This turns any selected tools off and leaves the screen blank. The Center Spot. This tool provides a single point temperature measurement. The Hotspot. This turns on an area box with the maximum temperature indicated inside the defined space. The Cold Spot does the same, but with the minimum temperature indicated inside the displayed box. There are also two user preset options that operators can customize using a variety of measurement tools. To configure these, press and hold the user preset option on the display for 1 to 2 seconds. A submenu will appear. Select Add Measurement, and you will see 4 tools available, including Add Spot, Add Box, Add Circle, and Add Delta. Let's try Add Circle. Highlight that option and press the navigation pad to select. This places an area circle on the display with both hot and cold spot indicators. Use your finger to press and drag any of the four corners on the overlay to resize the shape. Tap off to the side of the shape to bring the submenu back up and select Save to preserve your new preset option. When you return to the main Measurement Tools menu, your new custom tool should now be available. The T-Series also provides the ability to customize these measurement tools. To demonstrate, let's put a hotspot area box on the image. Highlight the box by touching one of the corners so that an outline appears. Next, pressing the navigation pad or pressing and holding your finger on the screen will open a submenu with additional options. Use Local Parameters allows you to use local measurement parameters for this specific tool. This includes setting a custom emissivity, reflected temperature, and distance values. We'll discuss measurement parameters a bit more in the next section. The Max, Min, Average option allows you to add or change the spot indicators in the area box. By default, the hotspot area box has a hot temperature indicator. Highlighting minimum and selecting it by either touching the option on the screen or pressing the navigation pad will turn on a cold spot indicator. There's also an option for average temperature, which provides the overall average temperature inside this area box. When we return to the live image, the area box now shows the hot, cold, and average temperature values on the display. There's also a function to set an alarm indicator using the area box. Above and below options are available that can be customized to activate when a temperature value passes a maximum, minimum, or average threshold. Users can set this temperature in the next column and also add an audible alarm. Finally, here is where you can also move or resize the area box. However, I often find it easier just to use my finger on the display, where you can move and resize the area box by either dragging the corners or pressing and holding the center of the box to drag it around the display. While the T-Series offers a lot of functionality with measurement tools, it's important for operators to remember that all of these can be accessed and modified in your reporting software. When using measurement tools, you need to also adjust the values for emissivity, reflected temperature, relative humidity, air temperature, and atmospheric distance. These are known as measurement parameters. All five have an impact on temperature accuracy, with emissivity and reflected temperature being the most important. Navigate to the main menu and select Measurement Parameters. Use the navigation pad to highlight the desired parameter and press the navigation pad to adjust its value. Knowing the correct settings to use requires a Level 1 IR certification training at a minimum. For now, please make sure you're familiar with how to change these in the camera, and remember that they can also be adjusted in your reporting software. The nuke, or non-uniformity correction, is a function that resets the detector array and removes thermal artifacts displayed on the image. Now, these anomalies are created when heat generated inside the camera, or energy perhaps coming from the surrounding environment, affects the stability of the detector array. Now, these anomalies can appear to be warmer or cooler than the actual target, and are most noticeable when you move the thermal imager. The non-uniformity correction provides a cleaner image by resetting the detector and removing these artifacts. The clicking that you hear is a shutter that drops down in front of the detector inside the camera. Its purpose is to provide a uniform target for the detectors to reset against. The result is a better image that's more thermally stable and consistent throughout your inspection. You can force a non-uniformity correction by holding down the Archive or Playback button on the back of the camera. The image will pause for a moment while the shutter engages, providing you with a better thermal image. Now that we've introduced the camera, let's talk about saving images and videos with the FLIR T-Series Thermal Imager. Remember, the T-Series offers 3 recording modes for capturing data. These include single shot. This captures an individual thermal image. Video. This saves a thermal video of the scene. and Timelapse. This captures a sequence of images that the operator can configure. From the main menu, navigate to recording mode, where you can set the thermal imager to capture a single shot, a video, or a time lapse. To save a thermal image with a single shot, point the camera at your target, frame it properly, and press the Save button on the front of the thermal imager. This will capture both a thermal and visible light control photo. When recording mode is set to video, pressing the Save button will start video recording. Pressing it once more will stop recording. Select Time-Lapse mode to configure the time-lapse settings. The first 3 columns allow you to set the time between each capture. The 4th column allows you to specify the total number of images that you would like to capture, with infinity being the first option. Press the Archive or Playback button to view your saved images and video. This will bring up a folder where you will find all of your media stored in a gallery. Press on the navigation pad to open the folder and browse through the saved images. Use the navigation pad to highlight an image and press the navigation pad once more to open it. It's here that you can review and edit your data. First, tap the image. This will reveal the image mode icon, which allows you to toggle between visible and thermal photos. The 3 dots next to the image mode icon opens a toolbar that provides access to additional features. Tap the edit icon to open the image and make adjustments to span and level. At the bottom of the display, you should see the main menu icon. Open the main menu, and it's here that you can adjust your measurement parameters and your image mode, including MSX, add measurement tools, change your color palette, and save any edits that you might make. Pressing the back button returns you to the main image. Navigate back to the toolbar, and you'll also find options to upload this image to your Ignite account, add notes to your saved image, display the image information, or delete it. Finally, while in the main image viewer, swiping left or right also allows you to browse through your saved images. And if you want, you can offload these onto your computer by connecting your camera using a USB-C cable. However, there's a better way to do this now that has revolutionized how thermographers save and manage their thermal data, and it involves FLIR Ignite. FLIR Ignite is a cloud-based data management system that saves your images, keeps them organized, and provides the ability to generate reports. Users create an account and, when connected to Ignite via Wi-Fi on their thermal imager, any images they save are automatically synced with their account. To get started, let's first set up an Ignite account. Open a web browser and head to ignite.flir.com. Click Sign Up or Sign In to create an account. Enter your email address. This will be your username. Then select Continue, where you'll then be prompted to enter and create a password. After reviewing the terms and conditions and acknowledging that you've read them, follow the prompts that introduce you to Ignite and its many features. Now, Ignite offers a lot, so we'll be covering more of that in another tutorial. For now, just make sure to get your account established so that we can connect your camera. Now that we have an Ignite account set up, the next step is to connect your thermal imager to a Wi-Fi network. This will allow us to sign in to Ignite and start syncing our images. To connect your thermal imager to Wi-Fi, go to Settings and select Connections. Turn on Wi-Fi and select an appropriate network. Remember, you'll need your network key or password. Once connected, navigate back to the main settings menu where you can sign into Ignite and pair the thermal imager to your account. To pair your thermal imager with an Ignite account, navigate to the camera settings menu, tap the FLIR Ignite option at the top of the screen, and select Sign In. Here you'll see 2 options for connecting a camera. A URL is available if you prefer to do this via a web browser, or you can use your smartphone camera to scan the QR code. Let's try that. Open the camera app on your cell phone and look at the QR code. a web link should appear. Click the link and you'll be redirected to the FLIR Ignite website. Once the page comes up on your phone, sign in using the username and password that you just created for your new Ignite account. Once logged in, the 8-character pairing code displayed on your thermal imager should also automatically appear in your phone's web browser. Select Start Pairing and wait for a confirmation to appear that it has been successful. The camera display should change and your registered name will now show up. This confirms that you are now connected to your FLIR Ignite account. Press the back arrow in the upper left corner to back out. This should display your account information, including your email address, a status bar showing how much storage remains on your account, and an option to switch auto upload on or off. Let's leave it on for now to take full advantage of Ignite's ability to back up our thermal data. We hope you enjoyed this overview of the FLIR T-Series Thermal Imager. If you have any questions or need additional help with the camera or software, the following pages are available for thermographers on the FLIR support website. Here you'll find a summary of key features, additional technical information, user guides, frequently asked questions, and much more. However, learning how to use the camera and software is just your first step. It's only with certification training that you'll get the most out of your investment in this technology. And that's where the Infrared Training Center can help. Increase your credibility, enhance your career, and build your business. These are just some of what you'll accomplish with certification courses from the Infrared Training Center. Whether you're joining us in the classroom, on-site, or online, our course schedule is packed with upcoming training dates at a number of convenient locations worldwide. Learn from industry veterans and thermal imaging experts who will help guide you through an interactive and practical educational experience with training that meets or exceeds industry standards.
I would 100% recommend this program to friends or colleagues. A little bit of knowledge with this technology can really go a long way and alleviate these problems that affect us all.
Don't wait. Join us for certification training with your T-Series Thermal Imager. To register, give us a call or go to infraredtraining.com to learn more and start your journey towards certification with the Infrared Training Center.